Hello, and welcome to the Tour of Go exercise walkthroughs. Today's video covers the third exercise, maps, from the basics chapter inside of the more types, structs, slices, and maps chapter. Rather than just showing you my solution directly, I will explain all the necessary golang concepts in context for you to impart with a deep understanding of what each and every single line of code really means. We are tasked to implement word count. It should return a map of the counts of each word in the string s. The wc.test function runs a test suite against the provided function and prints success or failure. You might find the strings.fields helpful. Basically, we're given some input string and should count the frequency of each word in that particular string. Let's take a look at the provided starter code. As per usual, package main is declared. It imports a package called wc from this particular path. As in the previous exercise, this package is specifically designed by the authors of the Tour of Go to test the functionality of our code. Next, we have the function that we'll be implementing, named word count. It takes in a string and returns a map from string to int. And already a map literal with a single key value pair is returned. The main function makes a call to wc.test from the wc package, which is imported, and passes in the word count function, which we'll be implementing. Now, let's take a look and see what is behind this particular package. If we scroll to the bottom here, we can see the source files. We can see exactly which test cases are being run down here with some input strings and then the map output, which is expected. Now, when we run our code in this starting state, the tests fail, and we can even see why. The input string I am learning Go, what is returned? A map string x to 1, which is exactly what's being returned. And what is wanted? Map string int Go1, I1, M1, learning 1. So this is the map data structure that we'll be building up to. First, we will remove this return map literal. So let's set up our map. I'll call it word count is equal to make map string to int. So we use the built-in make function to allocate an empty map from string to int. And that is what will also be returned at the end here. Now we will want to add the words from the input string to the map. Luckily, we have been hinted to use the strings.fields function. Checking out the documentation for fields, we see it's a function takes in a string and returns a slice of string. Field splits the string s around each instance of one or more consecutive whitespace characters as defined by unicode.isSpace, returning a slice of substrings of s or an empty slice if s contains only whitespace. Every element of the returned slice is non-empty. Unlike split, leading and trailing runs of whitespace characters are discarded. So this function does exactly what we want. In essence, it splits on whitespace characters and returns a slice of substrings of these splits. Now let's make use of this function. We can say words is equal to strings.fields of s. And of course, we will need to import strings. Okay, so we have our words. Now we want to iterate over them. And to do this, I'll use a for range loop, as we've done in the previous exercise. So we can say for word range words. In this case, I've ignored the first returned element, which is the index. We will only be using the word directly, so a copy of the element in the slice. Now for each word, what we'll be doing is checking whether that word is present in our map or not. If it is already present, we'll update the count. If it is not present, we'll create a new key value pair with a word as the key and 1 as a new value. In Go, we can get the value and check the existence of a key at the same time. So we'll go count, okay, word, count, word. This is similar syntax as indexing into an array, but rather than an index, a numerical index, we provide the map key to get out the value. And the first return value gives us the actual count, and the second value, okay, holds a Boolean value indicating whether or not the particular word is inside of our map or the key is already stored in the map. So which value will count take if the key is not in the map? Well, it's defined to return the 0 value of the value type, that is 0 for int. All right, so let's check. If okay, so when the word is already there, we'll add 1 to the count. Word count, add word, is equal to count plus 1. Otherwise, word count, word is equal to 1. So here we have an update operation and here we have a set operation. We've already seen in the first exercise that we can use an if with a shorthand. So we could move this entire statement inside of the if, separate it with a semicolon, and we've cleaned it up slightly. Let's now run this. And we see all of our tests are passing. So let's remove all of the loop body. And all we'll do is say word count at word plus plus. The reason this works is that the lookup of a non-existent key is defined to return the 0 value, in this case 0. So when we loop over the words and we encounter a word that's not already in the map, the lookup will return 0, and then the plus plus operator adds 1 to whatever we have stored already. So we've kind of stored, we can think of it like 0 has been stored in the map for the particular word. We add 1 and store that new value back. And then of course, in the other case, if there's already a value stored, we simply add 1 to it. And that's the beauty of 0 values in Go. Just to confirm this works, we can click run again. And all our tests are passing. Great. So in summary, our little function here, it creates a word count map. It splits the input string on white space using the strings.fields. It iterates over all of the words based on this strings.fields return value, and then updates the frequency of each word in the map. And finally, that map is returned. And that's it for today. I hope you've gotten something out of this explanation. Thank you so much for watching, and I'll see you in the next one. Peace.